And as we have already seen in the inaugural session, so what I intend to do is take you through the journey of ISRO starting from the early days. Probably we are all very familiar. So way back in 1947, when India got its freedom, it was struggling to provide food, shelter, and education to its citizens. So at that time, in 1957, one very important event happened in the world. Russians put their first object into space called Sputnik. This was in 1957, and India was a fledgling democracy at that time, struggling to provide food, shelter, and education to its citizens. But we had great visionary scientists like Dr. Vikram Sarabhai, who was looking at how this capability of humans to go beyond planet Earth can make a difference to the lives of Indians in their desire. So what we are telling is Dr. Vikram Sarabhai was looking at how this ability of humans to go beyond planet Earth can make a difference to the lives of the people in the country. So one of the things that happened at that time is he could convince his friends across globe, Americans, Russians, Germans, and French, and through them got sounding rockets, which were actually rockets which could take objects up to 30, 40 kilometers into space. Sounding rockets were brought in the form of kits, and it was assembled in Tumba Equatorial Rocket Launching Site. And there it was launched initially, and the first such rocket was put into space by India in 1963. And then using this basic capability, India started learning its way of building rockets, and gradually it developed a capability. Another very interesting thing that happened at that time was for doing these rocket experiments, Dr. Sarabhai had to convince the fishermen in that beach by telling them that if you vacate this place and allow us to conduct some experiments, one day the country will benefit. And for that, even he had to make use of the services of the priest of that a church in that place, and through his help, he was able to initiate the activities at Tumba. And in 1975, India conducted world's largest socio-technological experiment. See, as you can imagine, early 70s, etc., the India did not have any capability to do broadcast service or provide information across the country. And at that time, only 4 metros had the privilege of seeing any broadcasting, television broadcasting. So what Dr. Sarabhai did was he convinced Americans that they should allow us to borrow one of their advanced technology satellite called ATSF, and it was moved over to Indian longitude. The way it operates is, probably you're all very familiar, that if you take an object and want to put it into orbit, depending on at what height you have taken the object, you need to give a specific velocity at that height for the object to go into a circular orbit. So if you give that specific velocity called the critical velocity, then exact equivalent value will take it to a circular orbit. But if you give more than that, the point where the object is released becomes the perigee and the other side becomes the apogee. But if you give less than the critical velocity, then the point where you release becomes apogee and the other side can be, it will go to a lower altitude, and if it does not have sufficient velocity, it will go and hit the earth itself. So at any given height, you require a critical velocity for going into a circular orbit. And typically, the orbits in the 600 to 1,000 kilometer range takes about 100 minutes to go around Earth, roughly 1.5 hours. And then you also know Moon, for example, which is a satellite of Earth, takes 28 days to go around Earth. That means between the 1,000 kilometer to the Moon's orbit at almost 3.8 lakh kilometer, there must be one height where the period of the satellite becomes exactly equivalent to the period of Earth's rotation in its axis. So what happens in that case is the satellite goes around the Earth exactly in 24 hours. And since Earth is also rotating about its own axis, if you look at the satellite will appear stationary to you. That is because you realize many times when you are traveling on a train, adjacent train which is going on a parallel track, if both of us are moving at the same speed, the other train appears to be stationary to us. So the relative velocity becomes very close to zero. So in the same manner, for a geostationary orbit, that is a satellite put at 36,000 kilometers altitude in the equatorial plane, the satellite appears to be stationary to us on ground. So when we want to cover larger and larger distances, we go to different heights. So this satellite is almost like a tower at 36,000 kilometers. And as a result of that, from this tower, 1/3 of the globe becomes visible. So line of sight communication is possible for this entire 1/3 of the globe. So using such a satellite, by line of sight communication, if you send a signal from the satellite, it can be picked up anywhere on the Earth in this globe, 1/3 of the globe, and then you can do constant communication with the satellite. This is what is a geostationary satellite. And what Dr. Sarabhai did was he convinced Americans that they should allow us to borrow one of their satellites, which they were building, and then making use of it, provide broadcasting service. So what India did was in 1975, it did a program called Satellite Instructional Television Experiment. In fact, this year happens to be the 50th year of the event, and we will be celebrating the Golden Jubilee event of this site. So what site did was, using the American satellite in India for 1 year in 2,400 villages of 6 states in the country, the broadcasting was done from the satellite, and using a black and white television set made by ECIL and a half a rack equipment built in Ahmedabad. Today we are all very familiar with a small quarter-meter antenna on the rooftop and a set-top box is sufficient for us to see a program on our television. So you imagine in 1975, India demonstrated this direct-to-community set with a 10-foot diameter antenna and black and white television sets of ECIL. And in these 2,400 villages, people were able to see the TV programs which showcase to them about various health aspects, agricultural practices, and various other information. And this was demonstrating to the country at a time when only 4 metros had the privilege of seeing television programs. Only Bombay, Delhi, Calcutta, and Madras had the privilege. At that time, ISRO demonstrated to the country that using space technology, you can rapidly bring in information to the masses and to the people. And in addition to this, the communication, when you can do from the geostationary satellite, you can rapidly link various people across the country. So using this particular experiment, which was demonstrated in 1975, India started its INSAT series of programs. And then 80s onwards, India started providing to its citizens both communication and broadcasting as a service. And prior to this, one more thing that had happened was Dr. Sarabhai had also made, like he promised the fishermen that if you allow us to conduct the experiments in these beaches, one day the country will benefit. One more development happened by putting satellites into orbit, which looks at the color of the ocean. That means by looking at the color of the ocean, you can determine where the chlorophyll is, and through the chlorophyll, the food chain of the fish, you can find out. And from that, you can tell where in the ocean, if a fisherman goes, he is assured of a fish catch. So you are familiar, India has a coastline of almost 11,500 kilometers. And this long coastline provides for lakhs of fishermen livelihood when they get into the ocean and catch their fish. Now, by this process of observing from space and identifying where in the ocean a fisherman is assured of a fish catch, when this information is provided to the fisherman, what happens is not only is he assured of the fish catch, but also the amount of fuel he has to spend. The petrol and diesel gets reduced, and the country saves huge amount of money in this. And this capability alone saves to the country between 10 to 15,000 crores a year because of the amount of petrol, diesel saved, and the time that the fisherman saves and his assured fish catch. In addition to this capability, today what India has done, it has also done using space technology, navigation capability, which I'll touch upon a little later again. But today, a fisherman carries a mobile in his hands. Though this mobile does not have any connectivity to the terrestrial tower, it can actually communicate with a small battery operated gadget which is fitted into the boat of the fisherman. And this gadget receives the signal from NAVIC satellites, and then the mobile, after communicating with this gadget, is able to show in a video compass mode where the fisherman has to can go for catching the fish. Like you're all familiar, a magnetic compass shows a direction. In the same way, on the mobile, a video screen shows direction to the fisherman in which he need to go, and then the exact location where he can catch the fish is also pointed out in this. Similarly, the mobile in the hands of the fisherman can also give him alerts if the weather conditions in the coming days are going to become unbearable. For example, cyclonic winds or very heavy winds, or if sea state roughness becomes variable and then results in not safe traveling on ocean. It also gives the alert to the fisherman in his mother tongue. Similarly, many times you would have read in the papers that our fishermen are captured by the neighboring countries when they cross their international boundaries. So this gadget mobile also alerts him that you are approaching such zone, be careful, so don't cross the boundaries. So you can see here what is happening. A person who does not know reading or writing is able to make use of a gadget and carry on his livelihood, and he is assured of his livelihood. So the technology of space not only enables the people to know about the livelihood and also enables communication, broadcasting, and in addition to that, another very important aspect that the space technology provides us is by looking at the region from a geostationary platform over India, and by looking at clouds and their cloud movement, you can find out what is a whole lot of things about the weather. And another thing you will also realize is when you are looking at Earth from space from a geostationary platform, you are covering a constant region. And if you are able to take pictures in different wavelengths, like clouds, and then by taking multiple pictures, you can locate the cloud in the frame. If it has moved from one place to another place, then you know how much it has moved in how much time, so you can find out the velocity. Similarly, you can measure temperature, humidity, and many other parameters from an orbiting satellite at geostationary platform. Today, India has built a large number of such geostationary satellite which is able to provide information which can be used for weather modeling and weather forecasting. And it is possible to tell when a cyclone will hit a particular coastal region. And you are familiar in the earlier decades, for example, there used to be large when super cyclone used to come. India has to in lot of Indians used to lose their lives because it was not known when such a cyclone will hit the coast region, and because of that, deaths used to be in the range of 10 to 15,000 whenever super cyclones hit the coastal region. But today, by virtue of geostationary platforms, being able to look at what is happening and then trying to tell almost in a, with high accuracy of both in terms of time and position. Today's it is possible to tell within half an hour in time error and about 20-kilometer positional error days in advance which cyclone will hit which coastal region. And as a result of that, our disaster relief agency people are able to evacuate people from that region and save their lives. So this alone also you can imagine provides a significant disaster alert activity, and India is able to save people's life. So geostationary platform gives you an opportunity to look at what is happening on Earth in a continuous mode. And also you can also realize that between the period of June to September, India is actually covered with clouds because of the monsoon period. But then you may wonder, what can we see from space if a cloud is covering the Earth? But then there are also other wavelengths in observation, like we can see through glass. Glass is transparent to our visible light. In a similar manner, in microwave region, that is another region of electromagnetic radiation, for that wavelength, cloud is transparent like glass to us. So as a result of that, having microwave sensors on the satellites, you can look at Earth and then make large number of parameter measurements. And using these kinds of different wavelengths, we can make many observations of Earth. So in a way, you can see what India started doing from the early 60s. It realized that going beyond Earth and putting satellites into the orbit, we can make use of these satellites and make observations on Earth. And using these observations, derive lot of information which can be beneficial for various activities. So the space technology is being used for communication, that means telephone connectivity. Probably some of you will also remember during your early days, school days, etc. If the in the family, if there is a new entrant, and if the parents have to tell the close relatives what has happened and they want to give the good news, many of them had to go to a telegraph office, wait for hours to get a connection. From that kind of situation in the 80s, today in your hand, you carry a mobile which can give you instant connectivity to any part of the globe and now even beyond Earth. So that means enabling communication and also disseminating information through television channels or through broadcasting service, and also by making a whole lot of observations telling about cyclones and then the other disaster related activities. For example, when you want to tell the people what is happening, the broadcasting and communication facilities can be used. Today alerts are being given in the even through mobiles. Similarly, a whole lot of other activities are being done using satellite. You can imagine in the early days, one of the experiments that was conducted, we talk of remote sensing. What is exactly remote sensing and how does it happen? Probably we also realize our own ability to look at the world is dependent on our five sensors. Our eyes looks in a specific wavelength region between 400 to 700 nanometers, and whatever happens in this universe in this wavelength region is we are capable of picking up through our eyes. And our system, our the processor system, or what is we are endowed with, takes these sensory inputs and makes sense of it. So whenever we are taking such inputs, apart from our touch sensor, all other things are actually a remote sensor. That means your ability to see things, hear, smell is all happening through the ability of remotely accessing information. So same way, space provides us a tremendous opportunity to look at what is happening on Earth by going far away from Earth. You also realize when you want to see something in great detail, you go very close to the object. But when you want to get a big picture, what is the background, etc., then you go far away from the object and then see. So, in the same way, the satellites provide us an opportunity to look at what is happening on Earth over the entire Earth uh, in the global portion of the Earth. So, because of this, initially, when observations and weather monitoring was happening, the limitation of the knowledge of various parameters of the atmosphere was only over land you could make observation. The three-fourths of the earth, which is filled with water or oceans, there was practically no information available. But then using satellites, when you started getting what is the sea surface temperature, what is the wind speeds in the ocean regions, you are able to get many of these information, and then using models you could fit and then predict what is happening in weather. So today's weather prediction has improved significantly because using satellite observations, it was possible to provide to the models inputs on how what is happening across the globe, and by making more and more measurements you are able to improve the models. Similarly, if you look at what is happening on earth, crop for example, if you look at wheat, sugarcane, rice, or a host of crops, using pictures taken in different wavelengths from the satellite over land, and then by taking repeated observations, you can make sure that how the crop is growing, what is the likely yield of crop this year. Many of those things are being done today using the satellite data. There is a center in Delhi called Mahalanobis Crop Forecasting Center, which makes use of large number of satellite data and then is in a position to give to the government well in advance what is the likely yield of various crops this year, and enabling the government to plan in terms of both either importing, exporting, or a host of economic activities. Similarly, it is also possible to do what is called as precision agriculture. During the course of subsequent talks, you will hear more and more about this. But my idea is only to bring you the whole how India evolved. So, like I said, initially it started demonstrating using even the access we had from other countries. For example, when I said the site experiment was conducted using a satellite borrowed from America. So similarly, a host of sounding rockets were brought, assembled, and launched. So India parallelly started building its own capability of building rockets and satellites. In the area of rockets, we started with sounding rockets, then built simple satellite launch vehicle, then augmented satellite launch vehicle, ASLV, then polar satellite launch vehicle, then geostationary satellite launch vehicle. So like that, step by step, we started building our ability to take satellites from Earth of different weights and put them into different orbits, initially for near Earth orbits, and then gradually geostationary, and then even to Moon and Mars going beyond. So launch vehicle technology was being built, and even here making the use of certain information that was accessible. But launch vehicle technology, you can imagine, is primarily a dual use technology. As a result of that, not many will be sharing the information with you. So you have to build that capability yourself. So step by step, starting in the 60s, India built this capability. And today we have the versions which are operating polar satellite launch vehicle, which can take satellites to different orbits and even multiple satellites into orbit. And then you have geostationary satellite, which makes use of cryogenic engines. And then cryogenic engines also initially, while one superpower was ready to provide as a technology, another superpower ensured that this technology transfer did not happen. And India, it was a blessing in disguise, because today we have built our own cryogenic engines, and then we are moving ahead. So launch vehicle technology was built step by step, and we have reached a certain level today where we are getting ready for putting man into space, and then we are thinking of building space station by 2035 and landing on moon by 2040, etc. So similarly, how we built our satellite technology is, again, when Russia offered to launch a couple of satellites and provided an opportunity, Aryabhatta was conceived. And then again, 19, in 1975, India launched Aryabhatta, and this year we celebrated 50 years of this actually path-breaking event for the country, where India built its own satellite, which was put into orbit by Russians using their launch vehicle in a cosmodrome. And then they also offered building or helping launching two satellites, Bhaskara 1 and 2. And India started developing its capability of going through the hands-on experience of building satellite and then launching. Similarly, Ariane, which was one of the launch vehicles being built by Europeans, they offered to put a satellite for us, and then we built a satellite called Apple Ariane Passenger Payload Experiment, which was the first three-axis stabilized satellite which was taken and put into orbit. So here you can see what India did was, whatever technology was accessible to it, it took, and then built on that our own indigenous capability. And today you have got satellites, more than 100 different types of satellites have been put in orbit. And then gradually we built remote sensing, navigation, communication, broadcasting, all these capabilities we built. And the way it went on, like I said, site experiment demonstrated to the government that across India, if you want to reach out and give information, space technology is the way to go, because otherwise, the alternate technology that was available at that time was using what are called microwave towers. Probably you would have seen the large microwave tower, and the way the communication happens in that is, every 1 kilometer you have to put a microwave tower. And India, as you are aware, is a 3.25 million square kilometer area. And if the entire country has to be connected for communication, etc., it would have needed a large number of such towers to be set up across the country. Both in terms of time and effort, it would have taken large time. So the satellite technology of going to geostationary platform was a cost-effective way, and government approved the INSAT program. And from the early 80s, India started building its own communication, broadcasting, and then weather monitoring, all three in one satellite. In fact, we were the first to put into operation such a three-in-one satellite for regular routine operations. And in the same way, India also demonstrated using satellite technology how we can provide opportunity for remote classrooms, and then also linking even patients from remote places like Andaman and Nicobar to super specialty hospitals. And all this was happening even in the 90s and 2000s, that using this technology of space-based communication, providing opportunities to reach out to the classrooms in the remote places. And then today you're all very familiar with the television operating as a virtual classroom, and even mobile operating as a classroom. But much before all these had been demonstrated using the space technology, we had our own EduSat providing certain capabilities. So here you can see what India did was use the space technology. And also you will be happy to know India is the only country which started space program for non-military application. Otherwise, every country which built its capability on space domain started the activity for military purposes. And it was the Cold War competition between America and Russia, which was actually taking them to make use of space for putting man into space and then whole lot of activity. But then in India, we had visionary scientists like Dr. Sarabhai, Homi Bhabha, etc., who are looking at how a fledgling democracy struggling to provide food and shelter to its citizens can make use of an advanced technology for rapidly changing the scenario on ground. So through this mechanism, communication, broadcasting, weather monitoring, then also disaster relief, and then early warning systems, all this could be brought into quick realization and quick reality using space technology. And even building this space technology, India made use of whatever technology was accessible, it took and then built on that. And here again, you can see many times people talk of what is called as a leapfrogging as a technology. What is a leapfrogging? Suppose you are required to do a, let's say, reach a certain height. See, if you have enough length and space available, a person who wants to reach that height can build enough momentum by running and then jump and cross a barrier. But then if you do not have that much space for building up momentum, you do what a frog does. Frog conserves all its energy and in one jump takes to a certain height. So same way, India adopted this leapfrogging technology. Whatever technology was accessible, it made use of, and what is not accessible, it built within the country. So in the early 70s, the people who came out of the age in the country worked together, and it was an era where it was unlike today. Information, if you have to get only from books or from journals, and journals which are producing various papers, etc. And then, whereas today, by virtue of internet and this, you can have easy access to information. So people who started their careers in ISRO had to build many things from scratch. There was no examples of things available of that happening in the country. So step by step, they built this capability of doing launch vehicles, satellite, and various applications of taking data from orbiting platforms and then going ahead. So as this capability was being built, it was also realized that if the country has to progress, you need more and more people who are trained and who are ready to take challenging activities. And how can you bring in more and more challenging activities into play? This is where the need for space science activity also grew. So right from the early days, India was looking at how each space activity can benefit science related development in the country. Like I pointed out, Dr. Sarabhai could convince United Nations and his friends across the globe that India has a unique place in Tumba. And near Tumba, we have a geomagnetic equator. And if you conduct upper atmospheric research there, it will be beneficial for the scientific community. That is how sounding rockets were brought there, and some payloads were put on those rockets and then taken to heights of up to 30, 40 kilometers. And using those payloads, some information about the different altitudes were generated. And then later, by using satellites, various science instruments were built. And India also decided in 2008, it undertook a program for Chandrayaan mission. See, as I was pointing out, India started putting its satellites into low Earth orbit for various remote sensing application, and then to geostationary orbit, which is 36,000 kilometers, for enabling constant monitoring of Earth and also providing both communication and navigation activities. And then Moon is at a distance of 380,000 kilometers. That means almost 10 times beyond our geostationary orbit. So both the process of taking a satellite to that altitude and the process of making that satellite go around the moon is all many challenging activities, challenges of computation, challenges of communication, challenges of communicating at larger distances. All these were step by step enhancement of the capability of the scientists and engineers working for solving the problem. So in 2008, when India launched this Chandrayaan mission, though man had landed on the moon by that time, a large number of probes had touched the surface of the moon. Chandrayaan 1 gets the credit for discovering the presence of water molecule and the process of water molecule formation on moon. So what this clearly showed is, though India started this activity much later, in science and technology area, it is never too late. You can always find something which others have not done. And this is the one key important aspect which we need to tell even our next generation. There is no need to feel that a lot of development has already happened and there is nothing new to do, but it is never like that. Science and technology always gives you opportunity to look at what is happening with a newer perspective and newer ways of doing. So Chandrayaan 1 gave that and showcased to the world that up to that point of time, moon was considered to be a bone dry. But then verifying presence of water and water molecules on moon changed the perspective of people. Today you are seeing a large competition of going back to moon, landing there, and conducting large number of rovers and sample return mission. All these are going on with respect to moon. Similarly, India also developed its ability to build satellites for doing celestial observation. Astrosat is one such example where India enabled a large number of academic institutions in the country like TIFR, PRL, IIA, IUCA, and many institutions in the country where scientists and engineers came together, built instruments which were put on our Astrosat, and Astrosat has already provided more than a decade of service. And you will also be happy to know that this satellite carried a telescope which provides certain in a specific wavelength region information which no other instruments operating in space is providing. That means here again, India demonstrated that while you do what you are doing, you can always do something which others have not done. Similarly, when 104 satellites were launched in one launcher, India demonstrated to the world that it was a kind of a record at that time. And again, during the Mars orbiter mission, you have seen how a vehicle, a country in its maiden attempt was able to successfully put a satellite into orbit of the Mars. If you have to appreciate the complexity of this mission, what happened in this is on the 5th of November 2013, India launched this satellite from Sriharikota. The task cut out for the satellite was travel a distance of about 600 million kilometers or 60 crore kilometers over a period of 10 months. And at the end of that period, this satellite had to be inside a cube in space. You imagine a cube of 50 kilometers. So this satellite had to be inside that on the day and time, 24th of September 2014, morning 7:30 a.m. to the second, this satellite had to be inside that cube. If it were not inside that, it would not have been possible for us to take the satellite into the orbit of the Mars. So by doing all this successfully, India demonstrated its technological comprehension and the ability to perform complex tasks. So in all this, what I'm trying to impress upon you is the technology of going to space in itself is a huge technological capability. But then India looked at this not for achieving simply that technology, but how to make use of this ability of going beyond planet Earth to solve problems we are facing in our country, whether it is providing food, shelter, education. In fact, today a large number of this information is enabling government in its governance activity, even in dissemination of dispersal of funds. For example, housing when it is constructed today using this information system, it is possible to tell what is the current status of construction for a specific time and place. Our navigation system enables identifying location, timing service enables timing, and with that, if you take a picture using a mobile, that picture is associated with a time and place. That means you cannot say, you cannot fudge. Same picture can be used for another place and location. So by this method of proving that an activity is linked to a particular time and space, monitoring is happening today in events like Manrega, where government spend thousands of crores across the country for providing various opportunities to the underprivileged for providing work. But then this space-based system enable not only monitoring but also ensuring pilferage and misuse of this capability, bringing in transparency. Today, India makes use of space technology for a whole lot of administrative activities, including when it is trying to monitor how the buildings are being constructed or what is the water management that is happening by providing information about water surface area, a whole lot of things. So in a way, India is the country which made use of the space technology for building step by step. It has also been used in the past for identifying places where the bore well can be drilled. And like you'll probably hear a lot of these details in the course of subsequent discussion. But my idea of putting together all this information and telling you is India made use of the ability to go beyond planet Earth for solving its day-to-day problems of communication, broadcasting, education, classrooms, and then providing telemedicine, teleeducation, and then health. In all these areas, it started enabling. But then, as it started building its capability using technology which is accessible to you, you take it, and what is not accessible, you do indigenous development. And that's how ISRO has demonstrated to the country that by enabling a whole lot of people in the country, companies, and then private entities, making use of them for building our capability. So enabling a mechanism in the country where the country has can grow. Today, you are also familiar, India from its low position in the economy has reached almost the fourth largest economy today. And by the time we reach our 100 years of independence, India wants to make sure that it reaches that top. If that has to happen, in one of the very dominant economy areas is a space economy. Space economy is said to be $1 trillion. So if only the government entities operate in space segment, India's ability to take advantage of the whatever growth that has happened in space technology will be limited. So government wants more and more people in the country to participate in the economic activities of space, which is going to be $1 trillion economy. And if India has to get at least 10 to 20% of this economy for its own commercial and then benefit, more people have to participate. So the government has opened up this activity for private entities, and all those space related activities which can be done in private domain where they can invest and make money from that will be is being enabled. Today, India is enabling through its policy and then entities like InSpace, improving the ability of the country to be a big player in space economy. So in this is where more and more people have to get into the zone of understanding space technology and then going forward. So like today, we are seeing that India has already decided that it's going to put humans into space. And as part of that, one of the our trained astronaut is going into orbit just in a day. And then he will be able to gain more experience. And by in the next couple of years, India will have its own launcher and taking a satellite or a crew module into orbit them around Earth, bring them back. It is planning to put the space station by 2035, land on moon by 2040. And then there's a whole lot of opportunity for using moon as a starting point for travel beyond into space. A whole lot of things are available. So if you look at all this, there is a need for India to comprehend this entire space domain more and more. And today, already through the mechanism of space tutor and many space labs which are getting set up in schools, the idea should be to make students, kids at a younger and younger level comprehend many of these concepts. If they comprehend this concept, then their ability to use it and find solution becomes that much better. And today, every human being, every child has such tremendous potential. Its potential is so enormous that if we are able to give enough stimulus to that, its ability to not only comprehend and participate in the development area becomes very large. So I'll just take you through one small narrative of how a human system actually performs to bring similarity between robotic systems which we build and we are trying to put it into space or into moon, Mars, etc., and making use of these robotic systems for learning about what is happening and what is the similarity with the human system. See, suppose today I take a robot and tell what a robot does. I will explain it as a robot is a system which is capable of taking certain inputs by way of maybe switches or by providing some mechanism. There may be a camera in that, or there may be a microphone receiving signal, audio signal, video signal. So the robot takes inputs and then it has got certain actuators which will help it perform. Suppose I have a waiter robot, it has its arms and legs, it can move, pick up from the counter and then bring and deliver the item to the people who are sitting on the table for eating. Or in a hospital, the waiter robot can deliver medicine to a place remotely without the human contact. So many. So the robot has an actuator which it can use for performing a function. There is a controller which takes the input it gets and gives instructions to the actuator for performing. So in that sense, the controller takes input and gives instruction to actuator. So in one memory, we are storing all this information for the controller to give instruction for operation. In another memory, we are putting what is called as self-preservation, fail-safe, self-sustaining information. So there are basically 5 elements in a robot which helps it perform its function. It takes input from sensors, performs it through actuators by a controller which has access to a memory for taking instruction and another memory for preserving itself and self-preservation, self-protection. See, if you map these 5 elements to the human system, you will realize that we are all endowed with 5 sensory organs for taking inputs. We have 5 karmendriyas for performing our external activities. We have a controller which takes these sensory inputs and makes sense out of it and generates its command initially by its own experience and storing in one memory. And there is also access to another memory which comes from the birth process. See, if you take this, what human being has been trying to do right from the early days is navigate his life in the world by looking at what is happening around, mimicking it, and then step by step building tools. So to start with, if you look at human beings were required to fight with bigger animals. When he found his hands are not adequate to deal with it, he picked up stones, made it sharper, fought with animals. Then he took sticks, started fighting with sticks, and converted that stick into a bow and arrow. Similarly, he knows his own walking. He can walk only a few kilometers an hour. he saw other animals moving much faster. He started riding them and then taking him to farther and farther places quicker. And then later on, he built wheels, cycles, and then using animal power for driving the vehicles. Then combustion engines, today batteries and motors, etc. Similarly, he saw birds flying. He has built aeroplanes to fly. And then he saw by naked eye, he has built telescopes. And now today he is taking telescopes even beyond Earth. So if you look at that, all aspects of human life, he is enabling the sensors and actuators that is provided to him go beyond its functional limits. So human nature has been observing nature and mimicking what is happening in nature. So if you realize this, your ability to communicate to the children that all of them are endowed with such phenomenal capability. And by looking at what is happening in nature and trying to comprehend that and bring into reality is where new innovation and new ways of doing things are possible. So what ISRO has demonstrated during the course of last many decades is how can the technology of going beyond planet Earth be used for development on planet Earth for a developing country, and it has effectively shown that it has come from a country which underwent many hundreds or thousands of years of external rule, has reached from a very low level of existence in terms of economic capabilities and living condition. It has reached to the fourth largest economy and aspiring to become the topmost in the coming decades. And if that has to happen, it is the next generation which has to make it happen. And to the next generation, if we can showcase that the potential they have is infinite, and if their potential they are able to visualize and start bringing into practice, India can move ahead. And all of you have a tremendous role in this. And if you discharge your role, I am 100% sure that India is going to reach its position, which it had occupied preeminent position in the millennia earlier. So this is the narrative which I wanted to convey to you. Primarily, human being has a tremendous potential, and if he becomes aware of that potential, he can bring reality to what he observes in nature. Today when people are talking about artificial intelligence, machine learning, quantum technologies, whole lot of that, all of that, there is an inspiration in nature, and if we can look at that inspiration, we can make things happen. So like I said, we are all travelers on this space platform, and then we want to find other similar, whether there are other similar platforms existing in space, exoworld, and then finding earth like planets elsewhere. All that is going on, and it is your ability to actually trigger the imagination of the next generation and then showcase to them that they have tremendous potential, and if that potential, they work together as a team, they can deliver. What ISRO has also done is showcasing that a host of people working in diverse areas of mechanical engineering to chemical, electronics, arts, you name every field, there are people working in ISRO. All of them working together have demonstrated and brought the technological capability of using space to a certain level. So if the students can be made to understand their infinite potential, their need to work as a team. And if you work as a team and have a big picture, then you can achieve great success, is the story of what ISRO has done over the last few decades. Thank you very much for giving me an opportunity to share with you this experience, and also wishing each one of you a great success in your own effort of becoming aware of yourself, and also becoming making your students aware of their capability and inspiring them to bring humanity to a level where it can tackle its problems of the future. Thank you very much.